All right, welcome to Gene Bites and the Roundtable today. Happy March Madness. Well, hopefully we won't get in trouble for saying that. Hopefully the NBA won't come after us. Welcome to Methyl Madness here at NGI. This month we are going to be learning all about methylation. I'm Dr. Chrissie Williamson, and I have my team with me today. I've got Samantha Menz. Say hi. I've got Laura Kelly. And I've got Michelle Gottfried. So a little bit later today, we are going to be putting out a little video on coronavirus, so stay tuned for that. But today we're going to walk you guys through what methylation is and kind of go through the basics of one-carbon metabolism and the methylation cycle, and just briefly talk to you all about what methylation is, what it does, and just kind of check it out, okay? So there's a lot of confusion about what methylation is and what it does. And this month we'll be going through some, different gene bites. We'll have a few little short snippets on, different pathways. So Michelle has one coming out later today that'll go through the three basic pathways of homocysteine recycling. So Michelle, you want to talk a little bit about what that will be this afternoon?
Sure. I just tell you what the homocysteine lab marker is and how we can look at it. So it's not just looking at that marker. We have to think about the upstream and downstream metabolomic lab markers, and think about how it's leaving the body or being recycled. So there's three routes, and I'll tell you a little bit about those in that gene bite.
Cool. Awesome. And then Sam is going to do the next one, and she's going to talk about our celebrity SNP. And what's our celebrity SNP, Sam?
MTHFR.
Awesome.
Sometimes.
Right. So we'll keep it clean, and we won't say what we call it sometimes behind the scenes. But Sam is going to talk to you guys about our celebrity SNP next week. And then the following week, Laura is going to talk to us about
COMT, and how it sort of affects mood and estrogen metabolism and all that good stuff. So one of my favorite SNPs.
That's my favorite gene ever.
Yep.
Yeah, we had a little fight at NGI over who got to talk about COMT.
I won.
Laura won. All right. So today on our roundtable, again, we're going to learn about the basics of methylation. So give us just a second, and we'll go ahead and get our presentation started for you. So hang on just a sec. I don't know why this always takes so long. All right, so methylation madness. Always fun. So because not everybody really knows what nutritional genomics is, I thought we'd start out with the basic definition of nutritional genomics, because when we talk about the concept of methylation, everybody thinks about this massive biochemical pathway, or how we're actually going to use this in practice, or if you're a patient, you're going to a doctor or a nutritionist, or a naturopath or somebody, and you're going, well, what exactly is this, and how are you going to use it? And there's just a lot of confusion. So again, one of our roundtables this month is going to be methylation myths. So we're going to learn about some of the pitfalls or confusion about that. So let's actually start with, well, what is nutritional genomics? Okay. So a colleague of mine, Jose Ordovas, he's, I don't want to call him a dinosaur in the field, but he's been doing this for a lot longer than pretty much anybody else. So he's a pioneer in this field. So if you look back here, this is 2004 definition, okay? And so, when we're looking at this, it's pretty amazing. This didn't get into Wikipedia until the late 2000s, okay? So like 2010, 2012 was when nutritional genomics actually got into common knowledge. And if you ask some doctors, even today in 2020, say, well, what is nutritional genomics? They've never heard of it, and they can't give you a definition. So let's explore this a little bit. So it covers the effects of nutrients on the genome, proteome, and metabolome. That's nutrigenomics, okay? And then there's nutrigenetics, okay? And the major goal of this is to elucidate the effect of genetic variation on the intersection between diet and disease. Unless you're a clinician, unless you're a researcher, you probably went, huh, what? That doesn't make a whole lot of sense, right? Even you guys that work for me, right? What? What'd you just say? All right. So the way we define it at NGI is that nutrigenetics is disease risk prediction. Okay, so we're looking at something like BRCA, for instance, or breast cancer genes. It's the way that you predict how much of a risk factor you have in terms of disease. Okay, so BRCA has like an 80% risk factor. Okay, so you can measure that, but not really. There's not really a marker that we measure according to that, something called an odds risk ratio. And then in terms of nutrigenomics, it looks at the nutrients that affect the genome, the proteome, and the metabolome. Okay, so these are metabolic markers, biomarkers. Okay, we can measure those. Okay, we can measure these things. It's a measurable effect on the genome. So all the things, all the bits and pieces, all the biomarkers that we can look at that impact your genetic expression. This is nutrigenomics. Okay, so these are the really important things that we look at that we can actually determine genetic expression. Okay, so there's an Instagram post that we put out this morning that talks about this. So if you guys want to check out Instagram, Nutritional Genomics Institute Instagram post this morning, it explains that a little bit more. But if you look at that, that's nutrigenomics, this little tiny little piece over here between health, diet, and genomics. Okay, so some pretty important thing that we're talking about here, just getting started. And methylation is this little tiny little bit way inside of nutrigenomics. So we'll be talking about this little pinpoint inside of this spot today. Sorry, I rambled on a little bit there. We'll get going. All right, so how do we apply this in practice, okay? So again, nutritional genomics is the measurable effect on the genome, all right? Again, those are laboratory evaluations, because if we can't measure it, and quite frankly, if you don't feel better, is it really working? Does it really matter? Who cares, right? We don't care, you don't care. And then the question is how do we actually measure the genome? How do we measure genetic expression? Again, that's metabolomics. If that sounds like a funny word to you, it does to a lot of people who aren't in the scientific world. These are sometimes called functional tests, okay? So at NGI, guys, what kind of functional test do we run? Okay, anything else?
One for pediatrics or someone who doesn't want to get their blood drawn.
Right, I personally hate getting my blood drawn. It's not fair.
Really good things. Hormone testing and stool testing, and we can measure lots of good stuff.
Yeah. So for our people that call like our biohackers, okay, so there are all kinds of things that we measure, all right? So this can include basic blood tests. This can do things like our cardiovascular test that we did last month. So all of these things are technically metabolomics, all right? And when we apply metabolomics, we're looking up and downstream of the gene mutation. Okay, so just so that we understand what we're actually talking about here, these are organic acids, amino acids, fatty acids, all of these things, exactly, hormone tests, stool tests. Sometimes we look at metagenomic testing. These are proteomics testing. These things are pretty cool. So all kinds of things can actually be applied to the genome, and we can actually determine what kind of genetic expression we have based on this. So this is all pretty cool, and this is all how we determine whether or not we are methylated or non-methylated, okay? So these are things that, again, as we're just trying to get used to some of the new words that we're talking about here, so that we're all on the same page. This is pretty interesting information. All right, so let's talk about methylation specifically. And like looking at this picture here, we've got these little ME groups, okay? So these are methyl groups that are attached to the genome. And what we've been talking about, again, is what's on top of the genetic code, okay? So our genetic code, it's interesting. It's kind of the blueprint, but it's actually what's on top of the genome that's important, okay? That's actually what controls genetic expression. This is epigenetics, okay? And the metabolome measures genetic expression, or epigenetics, okay? So that's the cool stuff that we're actually trying to get at when we're looking at precision nutrition. All right, so I'm gonna stop squawking and let somebody else talk here for a few minutes. All right, so let's talk about methylation basics.
So methylation is basically 1 carbon, 3 hydrogens that moves from one substance to another substance, back and forth, and it basically is turning on and off of our genes. That's basically what it is.
So super complicated?
Huh?
So super complicated?
It's super easy, and we're going to look at another slide. It shows all the things that it's doing in the body. It's really important.
Yeah.
And Laura likes this, so
Yeah.
you can talk about it.
Okay. Yeah, so this picture was actually on another Instagram, Facebook post for NGI. And I really love this picture because it's kind of the way that I visualize it is a methyl group is sort of like your mom. So it's your mom sort of wrangling the genes, and you can kind of see that it's like a tangle sort of capturing the gene and basically telling it to be quiet. So it's the master regulator, right? And that what else is mom? Mom is the master regulator of the house. So if your body's like the house, it's your mom going around saying, shh.
It's a true story.
Right? So that's part of why I just think it's a really great image and a way of thinking about how the methyl groups go throughout the body and are basically, it's about balancing what's on and what's off. And so it really is like your mom going around the house, making sure things are running smoothly and properly. So yeah, the tangle.
It's true. It's absolutely true. Mom is always the master regulator.
Yep. Yeah, and it's M methyl group mom. Like it works really well.
It's an easy way to remember it too. All right, so some of the things that people get caught up about the function of methylation, and so for practitioners looking at this, please take note. But for the average person that's listening to this, methylation impacts every single function of your body. Okay, so we're talking about turning on and turning off genes. It also impacts all of your biochemical pathways. So when you're thinking about, gosh, why is everybody paying attention to methylation? It's because it's so important. So it has to do with the way that your body detoxes. It has to do with your hormones. It has to do with your mood. It has to do with your energy. It has to do with pretty much everything. So this is really, really important when you think about, oh gosh, I'm just going to take a methyl group. I'm going to take some methylfolate, or I'm going to take these extra things. So we want to talk about that. We're going to talk about how that regulates in the body. But the reason that there's so much focus and attention on it is because it's so important in the body. So let's talk about that. So I'm kind of a Shakespeare fan, so to add or not to add a methyl donor, this is one of those things that we always kind of philosophically talk about, okay? So pretty important concepts. When you add a methyl donor, it's called hypermethylation, but when you add a methyl donor, again, it silences gene expression, okay? When you take away a methyl donor, it activates gene expression. So when we add methylated vitamins, do we think this is a good idea or a bad idea? Because remember, when we add in things like methylfolate or methylcobalamin or SAMe, it's going to turn off our genes, okay? So I love this cute little skit over here, and it's this methyl donor. It says, oh, hey, how have you been, DNA? I've got this cool idea to make a protein, blah, 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 blah. And the methyl donor just goes, no, you're not going to do that, okay? And it's Beatrice the biologist. It's this cute little meme. I love it. Okay, so it's just this one little thing to keep in mind, that when you're taking things like methylfolate, okay, that you need to keep in mind that you're turning off your genes, okay? And I always like to tell people, well, are your tumor suppressor genes working today? Hopefully they are. Is your skin genes working today? Did you make new skin cells? Are you breathing? Did your hair grow today? There are all kinds of things that we think about. We always focus on the teeny tiny little percent of things that don't work, and we go, yeah, we want to turn those off. But I want you to keep in mind that 99% of your genes, in fact, 99.5% of your genes, they work just fine. And if you start to turn them off, you're probably going to have more trouble than you had before. So food for thought, okay? I'm going to turn this over to Sam.
All right. So I'm going to take a bit of a deeper dive into this next week, so stay tuned. And I won't say who we used to call MTHFR in terms of the celebrity world, but basically it's a famous SNP or a famous gene, and we're not sure why. But basically I'm going to talk a little bit about the key variants, which you see listed here. Now take note that even if you are homozygous for C677T, for example, it's a 75% loss of function. Now note that that's not a 100% loss of function. So again, some food for thought there. We're going to talk about the cofactors, which are riboflavin, NADH, and ATP. And just to plant a little seed, notice that folate is not listed there. And then approximately about half of the population has at least one copy of this alteration, especially those within the Chinese, Italian, or Mexican ethnic groups.
Yeah, so one of the things that I get a pushback from all the time is that people are told, you know, you have MTHFR, you should take methylated folate to correct for this, okay? And we're gonna walk through the pathway here in just a second. But, you know, again, as Samantha mentioned, is folate listed as a cofactor? And the answer is absolutely not, okay? The cofactor, the primary cofactor here is riboflavin or vitamin B2. Okay, so this is really, really important as we're going through this biochemistry, and I promise I always say I'm going to take the teeth out of this. I'm not going to make it super scary, but we need to understand that this is what we need to be targeting. Folate is actually a methyl group. Methylated folate is actually the product. It's not actually the cofactor. It's not actually what drives MTHFR. All right, so as promised, a little biochemistry, but not scary, okay? So we're gonna walk through this really quickly, not super scary, but just enough so that we understand it, okay? So we start up here with dietary folate. This can actually process folic acid, which is synthetic, but what I like to tell people is that if you put folic acid in the system, it's like driving on the freeway at 5 o'clock traffic. It's not your friend, okay? If you take dietary folate, you're gonna be driving on the freeway or the beltway at, you know, 2 o'clock in the morning, smooth sailing, okay? No problem. But either one will go through, that's why it's listed here twice. But it's important because we get to what is actually the usable form of folate in the body, which is called tetrahydrofolate. You'll see a lot of people list 5-methyl tetrahydrofolate as the usable form in the body. This is not correct. But we'll start here at tetrahydrofolate. We're going to make 5,10-methylene tetrahydrofolate, which is our substrate for MTHFR. And then we have our celebrity SNP here, okay, MTHFR. Our cofactors again, FAD and NADP, okay, that's basically B2 and B3. Now, what this does is it makes a methyl donor, okay? And this is the whole point of one carbon metabolism, is to make this methyl donor, all right? And the methyl donor that it's created, the whole point that it needs to do is to get passed off into what is called the methylation cycle, okay? So this is as a methyl donor creation center, this is a methyl donor recycling center, and this is a methyl donor destruction center, okay? So 1, 2, 3, pretty simple, okay? That's all you really need to know about these pathways if you are just learning, okay? If you are gonna biohack and you're trying to modulate these pathways, then you can come over to Snippet and maybe learn a little bit more about them. But all you really need to know is that one carbon metabolism, or this pathway, makes a methyl donor. The purpose of MTHFR is to make the methyl donor. And once it makes the methyl donor, it has to pass it off to this enzyme here. Now, the important thing here is that this enzyme, you see it says vitamin B12, and you gotta have enough B12, okay? So important concepts, you gotta have enough B2 and you gotta have enough B12, okay? And those two things are what you absolutely have to be able to function in methylation, okay? Because if you don't have vitamin B2 to make the methyl donor and vitamin B12 to catch the methyl donor, okay, because this has to basically return back to tetrahydrofolate so that you can do it again, all right? This is a cycle. You want to make methyl donors over and over again for the body, okay? So once you pass this off here, it jumps into the methylation cycle, okay? And Michelle talks to you guys about homocysteine and the gene bite. So I want you guys to listen to that and what is important about this and how it's regulated. But once you come over here into this cycle, into actual methylation, this is where we have our methyltransferases. This is where we're going to come off here on this pathway and turn on and off genes and those types of things. But we have to be able to get the methyl group out of this circle over here. And to do that, we have to have vitamin B12. Okay, so those are the two things that are super, super important. If we were to add folate into this system, you know what would happen, guys? Folate trapping, right? Okay, so if you know anything about methylation, I'm sure you've heard about folate trapping. Okay, so if you add methyl groups or if you add folate into this system and you don't have enough vitamin B12, you're just going to stop the movement of this methylated folate. You're going to keep it here in this system and it's not going to pass go. You're not going to collect $200. You're not going to move on into the methylation system. Okay, so pretty simple methylation pathway. Make a methyl donor in this system, recycle a methyl donor in this system, and get rid of a methyl donor over here. But you must have B2 and B12 for these pathways to work.
I think what's important about this too, Chrissy, is that people don't quite understand is that it's actually about helping your body do what it naturally should do, rather than kind of forcing it by adding more. You're trying to help those genes work the way they're supposed to. And then your body naturally does this process. So it's a very different kind of perspective on, getting it to work the right way.
That's exactly right. Because when you take methylated folate, you're actually like, you're trying to, you're supplying it with a product, you're supplying it with the end product. And it's kind of like adding a sledgehammer, or a Band-Aid approach. And so the studies actually look at supplying the product, but it doesn't look at the gene-gene interactions. It talks about how it impacts homocysteine, but it doesn't control for the fact that people have genetic variation at methionine synthase, which was the name of this gene here, or at CBS, or betaine homocysteine methyltransferase. So, again, not trying to get too much into biochemistry, or genetic variation here, but there are all kinds of things where our studies are not exactly right in terms of the relationship between MTHFR and things like homocysteine.
And what they did too is they ended up with like that in mind. The companies that make multivitamins and things all ended up they now all have methylated folate in them, and it's based on kind of a misunderstanding, which sort of puts everyone at risk.
Exactly, because again, when you add methyl donors into the system, you are silencing gene expression. So we don't really want to turn off our genes.
It's like instead of too many chiefs, it's too many moms.
Right, which we don't want to have, that's too many cooks in the kitchen, okay?
Yeah, exactly. Literally.
I mean, you don't want to do that because that just causes chaos and unhappy ladies. Yeah. And Sam will talk about this in her gene bite, but when we're talking about certain things, and again, we talk about C617 variant, it may increase homocysteine, but this is really important to drive home here. This is when we're talking about those gene-gene interactions, okay? So the studies say that it's going to increase homocysteine. I say it may increase homocysteine, okay? And that's why we use metabolomics. That's why we measure and look at these different things, okay? So if we actually do have some of the impaired or correct metabolomics, then we have the risk factors that go along with those things. But it's really important, guys, to make sure that just because we have a gene doesn't mean it's active, okay? And that's why we measure, okay? That's why we're looking at metabolomics. That's why we use nutrigenomics. That's why we don't just look at the gene that you're going to get a spit out from, such and such a company that says, oh my gosh, you're homozygous for this, and therefore, oh my gosh, you're going to die. Okay, because that's typically what the reaction is I have this gene mutation, it's awful. Okay, so that's not how this works. You need to make sure that you're actually measuring and looking, oftentimes several steps above and below where the actual gene mutation is. All right. So again, it's an unjustified celebrity. Again, the biggest issues are actually above and below. And so, our biggest things that we do is we measure, again, looking at B12 and B2. For clinicians, that's methylmalonic acid and glutaric acid. All right, so overall, kind of pulling back out away from the pathway, away from biochemistry, because that might have been a little bit much for some people, the things that negatively impact methylation. So I'm actually going to turn this over to you guys a little bit. So who wants to chime in here? Don't be scared.
Well, I know we talk a lot about the different medications, so like methotrexate and metformin and antacids. And so, how it literally will sort of block that pathway. And so antacid and metformin, I believe, are the ones that really impact B12. So they're really creating a deficiency in B12, and then that's going to, of course, cause that folate trapping that we talked about, where methotrexate actually blocks DHFR,
Correct.
which means that it's going to slow down the processing of folate or folic acid into tetrahydrofolate.
Correct.
So, we don't realize sometimes that when we take these kinds of things that it really is having a pretty huge impact on the rest of the body, especially since methylation happens everywhere.
Exactly.
And we have to be careful with the high dose niacin, because a lot of people are taking that for various reasons, detoxification or cardiovascular disease. And we don't realize that that's actually depleting our methyl groups. And it is also a cofactor for an enzyme that degrades estrogen. So if we're blocking that enzyme, then we're going to have higher estrogen levels. And then the environmental toxins, heavy metals, those are blocking, also blocking enzymes that we need for methylation. So we have to look at all this. When we do a NutriEval, we're looking at your heavy metal status. We're looking at your detoxification genes. So there's lots of things we can look at to help you methylate well.
Right. And I think people underestimate the effect that stress can have on their, nutrigenomics or their genetics. So don't stress about your genes, because then it's going to cause something to stress about. Again, stress can cause the dysautonomia or dysfunction in that autonomic nervous system, and then it can turn on certain genes that we may not want to be turned on. So do some meditation, get a love tuner.
Yes.
Go out.
All of those things. It's exactly right. Yeah. So, I mean, when we're looking at what impacts methylation, again, pretty much everything impacts methylation, and methylation impacts everything, which is why it's such a big deal. Which is why when we're trying to measure methylation, when we're trying to look at someone's methylation status, we look at hormones, we look at nutrients, we look at diet, we're looking at stress, we're looking at environment, we're looking at pretty much everything. So, methylation is not just, oh, I'm going to look at a SAM-to-SAW ratio, or, oh, I'm just going to look at the three pathways that we talked about. Yes, the, one carbon methylation and, transsulfuration, that's basically the beginner's step to methylation. That's where you should start if you're learning, but that is this much when we're talking about what methylation actually is. So it's a big pathway. There's local methylation and global methylation. I was trying to say those two words together. But there are lots and lots of ways that we are measuring and looking at methylation status. So it's a big topic, and we're going to learn more about that this month. So we're going to talk about methylation myths and why methylation impacts more than gene regulation at our other roundtables this month. And again, Michelle and Laura and Sam are going to be putting out gene bites every week, again on homocysteine metabolism, MTHFR, and COMS. So be on the lookout for those. And then, of course, we're running a promotion this month. We'll be doing our mini methylation panel, but we are offering a free disease panel. So if you are going to book during Methylation Madness this month, you can choose basically an oxalate panel, a histamine panel, a dysautonomia panel. If you have an appropriate testing kit, so either an older 23andMe kit or some of the MyHeritage kits have them, but an ApoE panel is available. We can let you know whether or not the testing kit is appropriate. We are doing a ketogenic diet panel, a taster genotype, so why do I hate IPAs and Brussels sprouts? So if you're interested in those as well, you know, doing coffee, so the other ones are here as well. So, you know, I think some of these are pretty interesting. So, you know, if you have any questions about these, the cannabis one is really interesting as well. The sulfur metabolism one, and then of course the COMT metabolism one, looking at anxiety, estrogen, and insomnia. So, you know, lots of interesting things here. If you have not had exposure to genomics before, and you have any of these things kind of sing to you and go, man, that sounds really like me, and you want to find out if this is something that might be genetic, please contact our office or contact Sam and we'll get you scheduled. So thank you for joining us today on Gene Bites and our roundtable, and we look forward to answering your questions in our comment boxes. So again, look for us later on today. We'll be talking about coronavirus later on today. So take care and keep learning, guys.